Alright, how's it going, you guys? Hailin,
And Lucien.
and we're going to do a quick CAD video for you guys today. Just doing assemblies and lofts, a couple more advanced CAD tactics that might help you along the way. We're working with the card in general. So right now specifically, we're working with suspension, frame generator, and aerodynamic shells. And these two tools specifically are very important to what we're doing. So I'm going to run you guys through today on just how to put an assembly together, a more complex one up to this point. If you guys have been going through the inventor book, you may have done a couple, but this is kind of a real life situation with a suspension piece that we finished up a little bit ago. So we're going to put this together today. So to start up right away, like any assembly, you'll create a new part. So you'll click this button up here, and you're going to create an assembly right here. And we use standard, so you can just start up with that. So once you get that created, you have to start importing things. So if you look at the top, you'll notice it's not quite like a part when you start up. It has these assembly components. So with place, create, and you'll see a couple of these that might look familiar. But with assembly specifically, you aren't drawing any new parts. You're just putting them together. And so what you want to do is you want to place existing parts and assemble them together exactly as it would sound. So we're going to use Grab CAD, which if you're going to be working in CAD, we probably want to get you caught up with pretty quickly. It's where we are able to work together on parts so that you aren't just individually on individual computers. It's a lot nicer when you're able to collaborate with other people. And so we use this GrabCAD software. So we'll explain it probably later on if you guys want to get on it. Get in touch with us. But today we'll just be using this as a folder. So it's stored as just a normal folder on your computer. Once you open it, you get into kind of the solar car folder, and you can see all the years set up here. On right now we have 2019 under 2020 for some reason, but that's something else. But we're working with the 2021-22 folder this year. So in here, when you open it, you can find car frame assembly, aerodynamic models, and then new suspension, which is what we're talking about. In here, if you want, you can find the actual assembly, but we're going to put it together today, so we use the parts. We're actually have to open each individual one of these. It might take a minute, but essentially you want to start with the biggest component. So we're going to use the front stand. Actually, we're not going to use the front stanchion. We are going to use the swing bracket, swing arm. So we're using a single arm suspension this year. So right here, you can just place it by clicking it. And there's your part. Um, it looks just like a normal part when you place it, but again, you can't edit it in here because of course we're doing an assembly. And so I'll open up this folder again. We'll place our axle V1, and it's right there. And when you place these, they're just free in space, and so you have no idea where it's going to place until you constrain them with each other. And so a lot of the time to do these, you use either this join or constrain feature right up here. Join often allows you to do movements, so I'll show you that in a minute. But for this case that we're doing right here, when we put this suspension together, this piece just gets stuck in here, and then two bolts tighten it, and it gets locked in. So there's no movement there, which means we can just literally directly constrain it. So to do this, we're going to click the constrain button. And you can see all the different surfaces that we can do, but we want to do a middle to middle constraint here. So we'll take this middle section, and we'll click it there, and then we'll also click the middle section here. Here I click, and it goes. And oftentimes, more than not, you need two constraints to set something completely up. So right here, we notice that the axle went in backwards. It needs to be facing the other direction. So what we'll do is we'll take this constraint, we'll take the outside of this piece here. I don't know if it's going to let me select it. See if I can get the outside radius of it. I can also do it this way. Drag it out, and then take the outside radius right here, and attach it right there. And then what we can do, let's see, we gotta think about this for a minute. We have to flip it 180 degrees. Um, Actually, I'm gonna do this a little bit of a different way. We're gonna Control Z it all the way back to Windows over here. Actually, even before we place it. So when we place the axle, already know the direction we want to go. So right now it's backwards. If you right click, you see all these rotate buttons. So rotate along the Z-axis twice, and it's rotated. So we're going to place it like that. That'll save us a little bit of work later on. And so we'll do it again, center line to center line, just like that. And then we're going to do back face to back face. So right here, we're going to take this face. We're going to take this face. That's not going to work, actually. We're going to do this see if I can get it. That to that. Perfect. And so now if you notice, when I grab this, they move together because it's fully constrained. And so that's our initial suspension. As you guys can see, our bearings are going to attach to this, our wheels are going to attach to this, our hubs, everything that you can think of, it's all going to go right on here. So let's do the next part. We're going to import. Lucien, you want to do the hub or do you want to do the stanchion next? Hub?
Whatever.
We'll do the hub. Okay, let's do the hub. Where is the hub? Brake disc hubs. There we are. And we'll use the normal hub today. So the hub does go on the other way. So we're going to rotate this around twice, just like that. Place it, and it's in. So this one, there's actually a part that goes in here that's a bearing. So we're not going to put that in today because we don't quite have the CAD model ready for that. So essentially all we're going to do is we're just going to constrain the center to the center, like we did for the other one, just like that. And we are going to take, so the bearing, this step captures the left side of it, that step captures this side of it, which means this face has to be tangent with this step. So what we can also do is we'll take this face, strain it to face, and boom. Look at that, our hub's in. And so as you can kind of see here, if you use your imagination, there's going to be a bearing that's going to go right here, a bearing that's going to go right here, both of which are captured on this side with a step and a screw, and on this side with just 2 steps. Now, I don't know if you guys have ever seen a hub or changed a car tire, but it looks something like this. Essentially, this piece rotates along the axle, and then it is attached to the wheel via 6 bolts. And on the other side of it is the brake. What this allows you to do, which is a major bonus from what we have this here, is you can actually rotate the wheel on the axle and remove it without actually having to take the entire brake unit and everything off and have to readjust it. So it'll essentially allow us to make a tire change only around 5 minutes instead of the 25 minutes that we've been doing. And so as you'll see here in a minute when I place the wheel, let me go back a second, parts, wheel, right here. Okay, so there's our wheel. And right now it's not, actually this is the wrong wheel. This is the old wheel. We want to place the new one. Wheel insert, new wheel right there. Okay, so this one, well, you guys probably don't need to know, but this is what the middle cut out for the actual hub. The other one was the existing one that I cut out a little bit ago. But we can do here's again, if you'll notice kind of a trend, we're kind of doing center line to center line because we're doing a wheel. And then this right here is actually where I'm gonna. Actually, I'm probably not gonna use the join today. I'll use the join later. We'll use the just a normal constraint. We'll go center line. Let's see if I can select it here. Let's see. Let me do it. There we go. And then go into this one like that. And actually, it went to the right orientation right away this time, which is awesome. And so all we have to do now is we're gonna take this surface and put it along this one. So we're gonna go click. Oh, that's wrong. We're gonna actually constrain. We're gonna line up the wheel first. We're gonna take that. We're gonna line it up with any of these holes, just like that. Now the bolt holes are aligned. And then all we do now is we take this corner right here. Actually, we can take this one here first. Boom. And oh, wrong face. Take the outside. Wait, hold up. You grab that. There it goes. And so now we have the hub on the wheel, and it's all constrained together. So everything moves as one. It's all constrained. Nothing scoots. It's beautiful. So now we can actually build the suspension part of it, or no, we'll put the brake disc in. We'll finish out the wheel. So we have the brake disc right here, open. Is along the right orientation, not quite. Wrong axis. Again, wrong axis. Try our luck one more time. There it is. Perfect. So now you can see on the other side of the hub where this is actually attached. So these little holes right here, we're going to take the center line, attach it to any one of these. That one maybe. Oh. Oh, sorry, that was the wrong hole. My bad. I'm going to take this again and down here. Beautiful. And then we'll take one more because otherwise it's still going to rotate. So we'll take, come on, that one. Perfect. And then we can just take surface to surface, and then we should be there. So we'll go constrain, surface, surface. Done. And there's our brake caliper. It's on our wheel. And so the entire wheel portion is finished, unless you want to put a tire on this, which we haven't done yet. But what we can do is we want to build the rest of the suspension. So this is where you start getting into these parts right here. So you can see how this works. We're going to put a elbow anchor first. Make sure we're in the right orientation, just like that. And then align it, center, just like that. And so there's something interesting with this part I'm going to show you here. This piece is built to be just a tiny bit smaller than the actual piece because it's got to rotate. And so what we'll do, I'll prove it to you here real quick. If we take the measurement, so you press M as a shortcut to measure, take that surface to that surface, you can see it's 1.06 inches. And now if you come over here and you measure that surface, oh boy, to that surface, that's just 1 inch. So it's about 6/100ths bigger, which means if you divide that by 2, it needs 3/100ths of space on either side. So what I'm going to do here is I'm going to move this so it's just on that side. Eventually I like to be a little bit picky sometimes about this because it's just going to mention if I say 0.3 or 3/100ths of an inch, it's going to take it to the shortest distance. So it's going to be on this side if it's over here. It's going to take me to 3/100ths on this side if I'm over here. So I want it on this side. I'm going to constrain this face to this face as I normally would if I want to make them consistent. But right here in the offset part, I'll do 0.03 inches. Just like that. And you might not have noticed, but right here, it's going to leave 0.03 inches on this side. You kind of see it right there, and 0.03 inches on this side. As you can see, it's just right there. It's solid. Now, what we're going to do is we're going to import the front, the actual stanchion, the front stanchion. And so you got to be a little careful here because this piece isn't exactly symmetrical. Oops, I just rotated that on the wrong thing. Why? Nope. Again, the wrong thing. Oops. Sweet. So these guys got to line up right here. And so a quick way to do this is I'm just going to take this back face and take it to that. Right there. Now that's lined up. And we'll take these bolt holes. You want to apply that, and you can take the bolt hole 1. 2. That's locked. That's not going to go anywhere. Oh, I forgot one more actually. Sorry. We're going to take, this one's a little hard to see, but we'll take the back face of this stanchion and put it to the back face here. Solid. That's in. So this guy, again, everything moves as one. And you can actually see it rotate right here. And so that's part of the movement feature. But if you want to actually make things move, so if you had a gearbox and you want to test the motion, that's when you use the join. But we don't have anything to test with motion here. Just a little bit of rotation with the actual wheel and the spring that'll go here eventually. You can kind of see that movement right there. That's what happens when the suspension goes up and down. But for now, we're going to actually import the rest of the suspension. So we're going to place the header up here. Let me find it. Right there, the stanchion bracket. And then, actually, that's already in the right orientation. And so we can just constrain a couple of these together. Let's put these ones. You got to make sure that you put the right bolt holes together as well. And then we'll take one more right here. Beautiful. And then maybe these top edges just so it doesn't move. Actually, it's already done. Looks like it's just fine. So that's a suspension unit. Easy as that. If I move it up around, everything moves together. Nothing goes independent. Everything's constrained. Now, if we wanted this all to move like an actual suspension and test it, we would have used the join feature on a couple moving parts. For example, this axle here, the motion axle right here. And that's actually about it. So those would be the 2 points that we use the join feature. But just for sake of simplicity today, I use the constrain feature. So I'm going to give it to Lucien real quick to give you guys a tutorial on lofts and how we actually use it in aerodynamic designs.
Yeah, so lofts are like one of the most helpful tools in Inventor for complex shapes and stuff, but they're also like definitely one of the most frustrating things. So a loft, just you can create a new part, see if it loads, and we'll just create like the basic front of the car here. So we'll start with just a 2D sketch, and lofts can be used in like a few ways. You can just go for shapes from like a rectangle to a circle, just going up, and it'll make a nice smooth round shape up to that. Or you can do surface modeling and model the surface of something, which we'll do here for the front of the car. So if I know the car, do we want to just do like the front?
Sure, yeah, that works.
So we'll just create like, if the front's say 2 meters till we get to our widest point of the car, we can create just a line for 2 meters. And then we know our car is about, well, we don't know exactly what the width is going to be yet, but we'll say about 1,300 millimeters wide, but then we're just doing half of the car to start, and we'll mirror it across later, so we just divide that by 2. Then, just to create a nice round shape, we'll use a spline, and the spline will just go from these 2 points, and we like to make it tangent to that one, so when we line up the back of the car, it looks nice, and there's no sharp edges. And we'll just make sure both of these points are at the correct places, and we'll try and create just a nice round shape, relatively pointed and aerodynamic, and we'll change that later with aerodynamic testing. Then once we're done with that, we're going to actually use that as like one of our lines, and we can't have these other 2 lines in it later, so we'll just delete those. Now we can just finish that sketch and do the same thing with one creating the bottom profile or the side profile of the car. So just do another sketch along this plane, and actually we can project the geometry of this point because we know the length. Just go down from here. We'll just call our car about 20 inches down and go 90 degrees there. Now we can just create another spline that goes from front of the car all the way down to the back, and that looks like a pretty nice shape there. So that's it, but again we have to delete this line. So now you can kind of see where the car is, but we need to model a curve along here so it has something to loft to. So we can just create a plane. Like if you start a 2D sketch there, there's not a plane to create a line across there. So instead we'll create a plane, and we'll use parallel to the plane through point. We'll go up to the origin, find the correct plane. In this case it'll be the XY plane, and we'll go to this point here, which both should intersect with. Then we just start our sketch there. And then when we do our sketch here, we just need to project the geometry of these 2 points. That way we can work with those in our sketch. Now we can just create a nice rounded shape. Needs to stay pretty wide for a while down so the wheels fit in. And then we'll come back, right back to the start there. Now if you look from the top, you can kind of see you have basically an outline of the car, just the front little section there. And so now we can actually get into the loft. So now, just to loft, you just select loft, and so you can either do a solid loft, where you're working with like a shape that's filled in, it'll create something you can work with later, or you can just do a surface. So the surface allows you to just select a line, and so we can either select this line here and go to the point at the very front of the car, and it's sometimes hard to select points, so like you just need to get close and right click on one of the lines, and it'll say select other, and this will bring up this little thing here, and it'll be a drop down, and you can find point. Sometimes that won't show up, so you have to click it multiple times. And then you can use rails, and rails help you like guide your loft along instead of just going straight to it. So if you select the rails, you can select this rail here at the top, and then this rail at the bottom, and that allows you to control your shape. So now you can kind of see we have half of the front of the car already made, but this isn't really anything in space. Like it's just like paper thin. It doesn't even really have any thickness. So in the end, you will need to thicken it. So there's 2 ways to do that. One, the easier way is just to use the thicken offset tool, and this will just basically allow you to thicken it. And we just go super thin because we're just using this for aerodynamic models, and it doesn't matter what the inside of the car looks like. And then you can select which direction it's thickening. So we like to go to the inside because then we can keep our outer dimensions the same. Just hit OK. And sometimes like it says this, just that it can't get the tolerances quite right, and that's okay, just because it's a curved shape. So we'll just accept that, and now we have a nice little thing to work with here. Now we can use this one, which is the mirror tool, and we can just mirror this across the YZ plane to create the rest of the front of the car. And then you can see that just mirrored the surface again. So we can also mirror the solid across. And we'll just let it load. Sometimes these round shapes are not exactly happy with the computer. And there we go. So now you can see you have the front of the car. Is that pretty much it?
Do you want to show them the actual the lofts that we did with the full car? I think it's in your other inventor file. That's open right now. Should be able to just switch between.
Did you get that one working?
Yeah, we did.
Yeah, so here's the full car that we've created so far. This is just kind of our first relatively accurate model. So we basically used a lot of lofts for this one.
Yeah.
Like we have a loft here. Well, here, this is the actual draft of the car without the wheels inputted. So we have a loft that goes here.
Yeah.
And then we have multiple lofts in the back here.
Yeah.
And then this, we did a loft on top, and we actually were able to do the top completely in one loft. And then we did multiple lofts for the cockpit. And then we just made sure they were all together, thickened them, and then mirrored them across to create the full car.
Exactly. Yeah, so that kind of covers all lofts and assemblies, and that's just really a tiny part of what more advanced CAD is, aside from just extrusions, 2D sketches, and building simple things like that. But as you know, if you ever need help with these things, we'll probably get you working on some of them. Give us a shout. We'd be happy to help out. There are tons of people around who know a lot about these, probably more than us. And don't worry if it fails. I mean, like building this model that you see right here, we had hundreds of.
All these solids that are like this are failed ones that you can't delete. And then you can see there's still a lot of solids. So 45 attempts basically it took.
So don't worry about it if it fails. It's very frustrating. I've banged my head a couple times on the table trying to figure out why in the world something wouldn't thicken and would loft. But you keep trying, you'll get there. I think that kind of covers everything
That's
that
it.
we were going to talk about today.
Yeah.
So good luck, you guys, and enjoy the rest of your day.
Thanks.